For those that don't know me, I'm Andy Sheilds. I'm the Qualifications Manager for Physics and Environmental Science. That's my current portfolio. In the past, I also managed chemistry and half the engineering portfolio we have at SQA, because I've been there now for 20 years. Before that, I was a physics teacher in Ayrshire for 17 years, so I am as old as I look. Norman asked me if I could come along and talk about advanced higher physics projects, because obviously this session we have brought back all of the coursework. I mean, there were some subjects that brought them back last session, but science has gone for this session instead, as things kind of start to move back to more normal times. First thing I would say, there are no changes at all to what we were doing prior to the pandemic. Okay, so we haven't changed any of the documentation for any of the levels. So kind of, if you were doing something before the pandemic that worked well for you, then my advice would be get that out again and do it. Project task that has the general information about it, it has the marking instructions, it has the candidate's guide. Right. And the candidate's guide obviously is quite possibly the most crucial part of it. And what we'd always say to people is, give them that at the start. Don't wait until they're about to start write-ups and things like that, but actually right at the start, when you're with them and planning what to do, make sure they've got a copy of the candidate's guide. I know it's online and they could get it there, but actually kind of my experience and other experience that teachers I've spoken to is actually the physical act of going, there's your candidate's guide, is sometimes more likely to make them read it than going, oh, by the way, you can find it on the website. But it is there if you need it. What I want to do today is, I'm not going to kind of concentrate on marking instructions or things like that, because it's not about a marking exercise, but look at some of the instructions for teachers, lecturers, some of the conditions of assessment, some ideas around, resources, things to look out for, and what have you. Oops, jumped too fast. I've uploaded this presentation to the desktop, and I'm sure it'll be shared with you afterwards. So those are live links directly to the course assessment task document. But first of all, it's probably important to cover some things around the conditions of assessment, because at Advanced Higher, it's different from National 5 and higher assignments. Whereas there are parts of the National 5 and higher assignments that have to be done under effectively test conditions when they come to the write-up. For Advanced Higher, the conditions are more relaxed. It's an individual piece of work per candidate. It's a fairly chunky piece of work per candidate. We have had reports of all sorts of shapes and sizes over the years. The record is one that arrived bound in 3 volumes. With, I can't remember how many 100 pages in it. I'll come to the word count later, but actually it was all right, because it was mostly data type thing. So they've got to work individually. There can be no group work at Advanced Higher, no collaboration, collusion between them. But we don't prescribe what materials they can have or they can use. They don't have to be supervised at all times. Obviously, experimentally, you might be looking and saying, for health and safety reasons, they need some supervision while they're doing various things. Thinking back to my own class and classes that I had when I was a teacher, if they were using the Helmholtz coils and stuff like that, I was usually present just to make sure they didn't do something silly with the terminals. But the write-up part of it, for example, they can be doing that out with the classroom. They can be doing that at home. That's the usual thing that candidates will do for their write-up. Do it over time and things. A few things you can't do. You cannot provide them with any templates. You can't And something I have seen in the past is like teachers going, look, here's an Excel table and it's all auto-formatted for you to do the calculations. That's not permitted. They have to do all of this kind of work themselves. So no templates. It has to be their experimental data. You can't go, oh, by the way, I've got some really good experimental data, or I found some on the internet that's really good. This is about hands-on experimental work, not computer simulations, videos, something they found on an American school website from a science fair or what have you. It's not like National 5 and higher where they might be looking for secondary material to back up their findings. This is all about what they're finding. Okay. Obviously, health and safety wise, you may need to tell them how to use some of the apparatus, what have you, and you can provide what we call reasonable assistance. So, if people are struggling how to work a particular apparatus, you can go, this is how you do it. What you have to be careful about is the report stage. Because typically what happens is that candidates will produce a draft report. Not all of them. I have very strong memories, despite the fact that I've been out of the classroom for 20 years, of kind of going, as we come up to the deadline, Craig, I haven't seen your report yet. Oh, I'll get it to you tomorrow, sir. And tomorrow comes, Craig, I haven't seen your draft report yet. And then, it's the day to send them away, and I'm on the phone going, Craig, your report needs to come into the envelope, and never got a chance. And it was no surprise when it came back with about 9 out of the marks available. But they can produce a draft. You can, as a teacher, have a look at that, give them some generic advice. Has to be generic, though. What you can't do is be very directing and go, by the way, there's a mistake in the 4th line of your calculation there. That's too. But saying to somebody, you might want to check your uncertainty calculations again, is the type of generic advice that you could do, or think you need to go away and do a bit more on your evaluation. Because all they've written is, if I had more time, I would do, and that's not going to score them very many marks. So you have to be kind of careful about that. We have seen examples over the years where a marker has opened a report to find post-its. And those post-its say things like, this should be 0.715, not 0.517. And that's not acceptable. Those get investigated and kind of go back to the school usually and go, can you explain this type thing? So, yes, if you can get them to be working on the reports and draft the report and what have you, it's perfectly permissible to have a look and say, here's some advice and guidance, but keep it high level, keep it generic, rather than giving any particular detail. Okay, which is kind of what I've covered there. We do have a document which is linked there, which I'm not going to go into. It's a generic document about conditions of assessment. Okay. So, first part, obviously, is actually what we'd call your research stage. And that's your kind of where they go away, they've chosen their topic that they're going to investigate. Practically, that's usually from a list. I do, again, remember candidates coming to me, I want to investigate such and such, and me going, nah, sorry, don't have a kit. Pick something else. So often the most practical things within schools is you will have a certain kind of set of topics that you know that you've got kit for, or you can get access to kit for it, or what have you. Appreciate there might be people in here sitting going, we would normally use Glasgow University, and they've withdrawn their kind of support for the practical side of things. But one of the things I kind of would say is, and I'm looking around the room and seeing lots of young people who will probably go, what's he talking about? Heath Robinson style apparatus. There's nothing wrong with that. That's the kind of homemade, bits and pieces put together to do something. It worked when I was a teacher. Our Jaeger's method for viscosity was cobbled together from bits of tubing, Winchester bottles, that we nabbed from the chemistry department and things like that. But it worked. Might not have given the most brilliant result. But actually, when something doesn't give the most brilliant result, probably gives them more to talk about in their analysis and evaluation. So it's good kind of looking at some of the things that were there today. It was Grange Academy in Kilmarnock I taught at latterly. And all of our compound pendula were meter sticks with holes drilled in them. And a nail as the pivot point. What we didn't have, I'm looking at the kit that you had downstairs, and that would have been nice, but no, we just rigged things up. So, typically, you're looking at 3 to 4 related experiments. It could be fewer. Depends how complex and how long they are. I was talking to some people down in the lab about, I remember one of my own candidates who was using Strathclyde University's Cavendish Boys apparatus to find Big G. And he was there for about 3 days. So he did one extra experiment type thing because he'd already gone way over the recommended time for doing it. So typically what you're talking about is 10 to 15 hours actual experimental work. If it's coming in much shorter than that, it's maybe not going to be at the right level, at the right sort of suitable topic. It can certainly be over that if your candidates want. Remember being there with people appearing every blinking lunchtime. I want to do a bit more on my project. On you go, type thing. So there's nothing to stop them doing that except maybe your sanity and your time, what have you. But this kind of is meant to give you an idea of the sort of volume that would constitute a decent advanced higher project. Okay. So, one important point, and I got asked this one recently, can they use computer simulations? No. This is about hands-on experimental work. Okay. And because they're not needing to do things like find secondary sources to back up data, why would you go and do that type thing? So, no, you can't use computer simulations. They need to carry out a number of repeats appropriate to each experiment. That can vary, depends on what you're doing. I was telling Norman about a candidate that I had that decided he was doing viscosity of used engine oils. And the local garage had given us samples of 10,000 miles, 20,000 miles, and 50,000 miles. And then he decided that he was going to take my lovely little Ostwald viscometer and stick the engine oil through it, which took about 2 hours per reading. So he didn't do terribly many repeats when he was doing that. I wasn't best pleased with the fact that he was putting engine oil through the thing, but that was part of his kind of, I wonder if this will give me a decent result. So most experiments should be able to be repeated quite easily, but you might have some way of going, look, this is taking so long. But again, that's the sort of thing they can talk about in evaluations. Have you? And then they need to choose suitable range and interval of measurements that they're doing. Okay. That can, of course, change. I mean, one of the things that hopefully they'll start to develop is they might do an experiment, and the typical one is, there's maybe a turning point in a graph. Well, good practice that they go and have a look around that turning point, do a few more kind of measurements around there. So, that can be flexible as they're going through that as to how they would do things. Okay. I've mentioned about these things already, so I'm just going to kind of quickly go on to the next slide. So the other thing that they might be doing in the initial research stage is looking up stuff about the background physics. That could be, or these days is probably going to be, internet sources. Something I get asked frequently is, what about the use of Wikipedia? Well, that's always a debatable one. Actually, Wikipedia is probably the most moderated site on the entire World Wide Web. But on the other hand, I could go on to Wikipedia and put something on it that is just complete nonsense type thing. So again, this is the type of thing that you can do in sort of prepping your candidates. Tell them to look for academic websites when they're looking for these things, if they are using stuff. There's plenty out there, They have to be careful about things like, American high school science fair sites, because of course that's American school pupils' work, and there's no guarantee that what they've written is correct or reliable or what have you. So, when you're preparing your candidates, when you're talking about what to do, nothing wrong with saying try and look for suitable academic websites. Names that you would know, names that you would recognize. Okay. I would recommend personally, that they keep a daybook. A daybook is basically what you would have to jot down everything as you're working through. I know I'm old and what have you, but I remember being at my university labs and my daybook for that, which was just all the experiments I did, all the things. I would note down where I got information from, and that's important because when they come to writing up the report, it makes it so much easier if they've got everything in kind of one place rather than on umpteen different bits of paper on umpteen different files. Certainly could be digital, it doesn't have to be an old-fashioned jotter in which they jot down everything, but it's about getting them to make sure they record things as they go along. If they find a website that they want to use towards their background physics or underlying physics, make a note of it. So that when they go back, it's like, oh, there we go, I just need to reference that now, type thing. So encourage them to keep some sort of ongoing record. It also helps in terms of, you checking kind of progress with these things. I mean, the system I used to have, and in Grange Academy where I taught, we were the advanced higher sort of hub for Kilmarnock. So the other schools would send their pupils to me to do advanced higher. I used to put a spreadsheet up on the wall that I printed out with each of their names. Once they decided what they were doing, what experiments they were going to do, just put it up. And my methodology was to say, see, when you've completed something, tick it on the spreadsheet, and then that would allow me to go, oh, Louise, I see you finished your first experiment. Can I see your daybook? And that would kind of be that sort of regular checkpoint that we would have throughout. That worked for me, might not work for you, but possible suggestion as to what you could do with that. But it certainly did help when it comes to writing up. There's no scrabbling around. There's no kind of, oh God, where was that website again? Type thing. So, skip that one. So the actual topic must be, the word we use is commensurate with the level. Right? It does not have to come from the course. It can. We get lots and lots of investigation projects that do come straight from the course content, and that's absolutely fine. But equally, it can come from out with that. Very popular one is, Young's modulus of a wire by 3 different methods type thing. We don't do any statics at all in the advanced higher course, but actually it's a suitable thing to be doing. So it could be a mix, some things within, some things without. It could go beyond the level. I think, Cavendish Boys is a good example where it's like really quite complex to do and what have you. But I would kind of caution about making sure it's not too low a level. If you're doing G and you get the trapdoor and the ball out and you're doing, linear equations of motion, that's more higher level, really. So now that might be suitable as an introductory experiment, followed by 3 at advanced higher level type thing. But overall, you want to kind of try and make sure when you guide them that they're doing stuff that you think that's the right level. Right. I often get asked, why can't SQA give us a list of investigations to do? And we don't, because we don't want something to become a de facto list, which is what would happen. SQA say, here are the 20 possible investigations, and then my inbox would be full of, but at School X, we've always done this one. Can I do it still? And it's like, yeah, So we don't go down the route of going, here are the, topics that would work. I get asked, what's a good topic? What's a bad topic? It's not that there's a good or bad topic, because we get the same things that are written up really well and score highly, and written up really badly and score very poor marks. G is a classic example. I've seen G experiments or projects, that are scoring single figures because they're just so badly written up. And I've seen others that are nigh on getting full marks. So don't be fooled. I know sometimes on internet discussion fora there can be, such and such is really great and I always get good marks with it. That's down to the candidates writing it up well, not that the topic itself is necessarily great. Okay? It has to generate numerical data. Now again, there are things that might be nice add-ons that don't. Used to get candidates doing a lot of stuff around optics, and it was always a quite nice one that they added on some stuff about, lens aberrations and pincushion and barrel distortion and things like that, which wasn't generating numerical data, but it would be the kind of thing where we go, well, actually, I've already done sort of 3 of these things, so I'm going to take some photos of these things and put them in my report and talk about lens aberrations type stuff. But, you'd be looking for most of them to produce numerical data, and to produce numerical data that lends itself to graphical analysis. Okay? We want to push them down the road of doing things graphically. I know at lower levels in exam questions, we often allow them to do things like work out the constant, the proportionality type thing. We've always allowed it. Personally, it's always kind of bugged me, because I look at it and go, well, that should be graphed. But at this level, you want to be pushing them towards graphing. They can, of course, use IT for graphing. There is no stipulation that it has to be the, actually I've got some in my bag, the blue, pale blue graph paper. But the important thing if they're doing graphing using IT is they need to know how to use it properly. We see so many examples with, dot-to-dot lines, or what the physics markers refer to as bingo dobbers for points. Boom. Because Excel decides it's going to give you a triangle that covers about 5 minor scale divisions. So they need to be able to use it properly. We see some as well where, they get the Excel graph and then they copy it into their report and it's like, oh, right, I can't see that. So if they're using these things, major and minor grid lines, axes labeled properly, suitable point size, Advanced high, you'd want to be encouraging them to do, error bars if they can. That's always good towards their uncertainty analysis. Best fit line type thing. So, so sometimes, although we say you can use IT, sometimes with some candidates, the safest thing to do, if you can afford it these days, is to go, here's some graph paper. And actually, for some candidates, that's possibly a better thing than sitting doing it. But either is fine. You can agree their aim with them, and that's something to be careful about as well. Some of the odd aims that we see, we think that can't have been agreed by a teacher. I'm going to find out the best method of measuring G. Well, what do you mean by best? Was it the one that was most accurate? Was it the one that was most precise? Was it the one that was quickest to do? No. It was the one you enjoyed the most type thing. So, that's the stage you need to intervene and go, what do you mean by best? And then go, well, go and look at your aim again type thing. Agree that with them. If you're, rather than kind of letting them go down the road of throwing away lots of marks because they've done something daft at the start. What you can't do, though, is go, actually, your aim should be to see which of the three methods gives the most precise result. Resources. There are lots of resources out there on the internet, but there's also nothing wrong with. Now, this is the one that most physics teachers tend to use. They're long out of print, I'm afraid, so you have to get second-hand versions. And I'm not being sponsored for these, but that's Tyler, a lab manual of physics. There are different editions of it. Third, fourth, and fifth edition are all SI units. If you're back to the second or first edition, you're in CGS units. And actually in these things, they are great in terms of telling you what to do. If you are stuck with a first or second edition, you might have to point them in the direction of a website that converts CGS to SI for doing it. One thing I would caution with these is what the likes of Tyler does, and I've also got, this is my own personal collection, and probably might help fund my retirement when it comes around. This is Advanced Level Practical Physics, Nelken and Ogborn. There are different things in there. They tend to go through a derivation of the theory, but actually sometimes they make some quite major leaps in what they do. And that's something that kind of markers look out for, because they'll, they kind of know that, oh, right, this is one from Tyler. And it's like, oh, actually the candidate hasn't put those extra steps in showing how they got from there to there. That's the sort of thing that you'd want your candidates to be looking at and going, oh, no, I need to show how I derive that to get the better marks type thing. If they're just going, oh, I'm just going to put down what's in Tyler, they're not really going to be showing that much. But they are really useful. Armitage, Practical Physics in SI. There's another one that is kicking around on Amazon, eBooks, things like that. It is SI and not as one of my former colleagues. I'm sure he won't mind me saying this. He always used to refer to it as Practical Physics in S1. But I think that would shock your first years. So, and even, this is, there's no date of publication in this. Experimental Science for Schools, which came from Glasgow Training College for Teachers. back in the dim and distant time. And there are things in here, there's stuff that you go, but actually things like that. There's often stuff which, again, you could kind of go, we could mock up something along those. So yeah, look at internet sites, look at these things, but there are some kind of standard books out there. I do have more, but I didn't go up in the loft, retrieve them from boxes. I would say watch with some. There's a lot of kind of A-level sort of practical physics books on the market just now, and they're more about kind of, how would you answer exam questions about practical than actually here's practical work. The other one I was trying to find, but I think is in the loft, was the old Nuffield Physics series, because again they had some great sort of ideas for practical in them. So what about handing out old reports? That's something a lot of centres do, and my caution with that would be make sure you collect them back in again. I used to do that. We had copies of all the old reports in a cupboard because that was the kit that we had. And we would maybe at the start go, right, class, have a look through those, see if there's any you fancy, but at the end of the lesson I'd go in there, give me it back. There are lots of different, but what I'm trying to say is there's lots of different ways in which you could kind of, look for different ideas out there and things. And as I say, I know technician support is probably not what it was when I was in the classroom. I had a brilliant technician who I'd go, I found this thing in a book called a cohorts viscometer, and he was like, I'll rig you one up, Andy. And he did, using our air-bearing turntable and what have you. But people will probably tell me, not these days, no, we don't have a technician, no, the technician is a biologist or what have you. So, but there's lots of inspiration out there for different ideas. Okay. I don't know what sort of numbers you're dealing with, but the kind of rules around duplication of topics, if you have 10 or fewer candidates, they need to be investigating something different each. Okay. If you've got more than 10, then you could end up with duplication. I think where I was, it's typical, I maybe had 14, 15, 16 candidates per year from across the schools, and we had about 14 different ideas. So we always ended up with a couple doing the same thing. Yep.
If you have 10 or less, can they do the same topic if they're doing different experiments? So it's completely different methods.
Yeah, because it really is about the experimental procedures. G is a good one for that, in that you might have somebody that's doing G by, simple pendulum, compound pendulum, and if you're lucky enough to have links with Strathclyde or Heriot, what have you, go and use the Cater's pendulum type thing. And then somebody else might be doing bifilar, simple harmonic motion, things like that. So it's about the results, the processes and the experimental methods being different. So that's a possibility. Okay. But if you're looking at big numbers, and we have some centres in the past that have had 50-odd candidates doing advanced higher physics. And there's no way you can come up with 50-odd different ideas. So they would kind of have a set number. But the onus is then on the teacher to make sure that, right, the two people that are working on G by pendulum methods are not kind of going, do you want to swap results? And, can I just see what you've written for your evaluation? That would be the point at which, the teacher has to be saying, stop it, you two, it's your own work, type thing. So, and, it has to be their own data. And not just, as I once saw, 2 reports where one set of data was quoted to 3 significant figures, and in the other report, the same set of data was quoted to 4 significant figures. There was a 0 on the end of it, and I think they thought that was going to fool the marker and us, that they'd done it themselves. So report stage, as I've said, this is not timed. Okay, we do this by volume. Okay, I've mentioned a lot of that stuff already, so I'll skip over it. The volume is between 2,500 and 4,500 words. And yes, that is different from biology and chemistry. The numbers were arrived at simply by taking a whole pile of kind of fairly average reports from every subject and counting the number of words and then going, we don't want to penalise candidates for word count, because that's not really what the whole thing's about. You know? Yes, they do need to be able to write scientifically and summarise what they're doing, but you know, we actually went, and for physics, if we set it at kind of 4,500, it meant that there were very few candidates that were going to lose marks for being too long. And the same happened, that the chemistry and biology ones tend to be a bit shorter than that. So they're allowed a 10% over that. It doesn't quite take you to 5,000. I did ask when we set this up, could I have the upper number so that when I added 10%, it took us to exactly 5,000? I wasn't allowed. Type thing. So, but if they do go over, there is a penalty applied. And you might go, what's that penalty? Well, we've allowed them 10% extra. So if they go over, they lose 10% marks. That's 3 marks. Now, I've known some candidates and teachers have told me that some candidates go, stuff it, I can't be bothered shortening it. You know? I'm happy to take that. And it's that kind of balance thing. You really don't want them going over that in the first place. Type thing. They have to put their word count on the front of the flyleaf. Again, we've seen some daft things. Like I remember getting a packet in from a centre where all the candidates had magically done 4,400 words, going from the 10-page report to the 80-page report. Now, again, that red flags to the marker straight away, type thing. You know, so, but it doesn't include, as it says there, title page, contents page, you know, tables of data with the headings, graphs, calculations, references. This is about the bulk of the text, about your kind of writing up of the underlying physics, the methods, the analysis of results, of discussion, evaluation type thing. So
they can't go below 2,000?
Oh no, they can. Sorry, I should say that. Yeah, they can go below to
10% as well.
No. What they tend to do if they go below that is be what we call self-penalising. Now, if you're getting a report in that's like 1,900 words long, it's probably going to score poorly in a lot of areas. So the 2.5 to 4.5 is kind of came from, again, that thing was me. I sat in a big pile of things and counted words and went, that one's scoring pretty well, and it's 2,500, and that one's scoring pretty well, and it's 4,500. You know, type thing. So
no automatic penalty if
it's only over.
It's only over.
Yeah. Okay. Under, as I say, what you'll find is you read the underlying physics and go, they haven't told me very much, so I'm only going to give it 1. Now, or you get to their evaluation, and the evaluation of the project as a whole says, if I had more time, and I use that one because it's something they all write. If I had more time, I would have done more work, type thing. So instead of kind of actually talking about what they found out and the significance of their findings and, comparison of methods and things like that. So referencing, thought I'd cover a bit about that. At this level, we're looking for minimum of 3. But we look for 3 that have been properly cited and referenced. Right. Which prompts the question, what if they've got 7 and some of them are wrong? Well, we look for 3 that are done correctly to get the mark for referencing. Okay. And we allow them to do Vancouver style or Harvard style. In the course assessment task document, there are examples of both. The The broken links in the course assessment task document are to Imperial College London. They've now taken their PDFs and made them online links. And to be honest, and again, I'm not getting paid to say this, it's about the best kind of reference and site I've found for doing this. It really is good. It shows you how to do all sorts of different things within it. And have a referencing tool as well. So you can put stuff in and it'll go, ta-da, this is how you reference. I'll just copy and paste that into my report type thing. So have a look at it. Okay, that's a live link, by the way. So, and that's a kind of a sort of whistle stop tour.